Hi everyone, this is Mrs. J, and today we're going to be finding complex solutions for quadratic equations. Alright, so I have a quick warm-up for you guys, so please pause the video and give it a try and hit play when you are ready to check your answers. Alright, so here you were asked to solve the same quadratic equation using two different methods. So first, completing the square. Remember, we move our constant to the other side of the equation, and then we use the formula b over 2 squared to find our magic number, which in this case is 1. So we add that to both sides, and then this creates a perfect square trinomial. So if you factor this, we get x plus 1 squared. We get the same factor twice. Once you have this step, you can take the plus or minus square root of both sides. Don't forget the plus or minus. And then all you need to do is subtract 1 to finish solving for x. So your answers are -1 plus or minus square root of 6. Just note there are two answers here. One for -1 plus root 6, one for -1 minus root 6. Now with the quadratic formula, we should end up with the same answer. So here's our a, b, and c values. So you substitute them into the formula, simplify, and then here you do need to simplify square root of 24, which is 2 root 6. And then if you ever have a case like this, where you notice that both terms in the top are divisible by the term in the denominator, you can simplify a little bit more. So you'll notice that we get the same exact answer as when we did it with the, completing the square. So today we're going to be solving quadratic equations that don't have any real solutions, but they do have imaginary solutions or complex solutions. So here's just a recap of what we learned in the last lesson. We learned that we can now define the square root of -1 as I, which is an imaginary number. Again, there's really no way to take the square root of a negative number, but we're using this I value so we can still get some useful information out of our quadratic. And then another important definition to know is that I squared should always simplify to -1. So again, here's the three cases that we might get when we're working with quadratic equations. So you might get a parabola that crosses your x-axis twice, so you have two solutions. Or you might have a parabola whose vertex is on the x-axis, so you get exactly one solution. Or you might get a parabola that just never crosses your x-axis. So here we have no real solution, so 0 real solutions, but we are going to have complex solutions. So we're going to have solutions with imaginary numbers. So that's what we're working on today. So you're going to see today that we're going to be using the same methods that we've been using to solve any other quadratic. So we're going to start by solving this quadratic with the square root method. So remember, our first goal is to isolate x squared. So let's start by subtracting 8 from each side. So we get 4x squared equals -8. And then let's divide both sides by 4. So we get x squared equals -2. And now we can take that plus or minus square root on both sides. And we get x equals the plus or minus square root of -2. So in the past, this is when we would say, well, it's impossible to take the square root of a negative. There must be no solution. So this is no real solution, but we can describe this with an imaginary solution. So remember, anytime you have a negative inside your square root, we're simply going to put an I on the outside. So it's plus or minus I root 2. And these are our two imaginary solutions. So you'll see that the whole process of solving is exactly the same. The only thing that's new is really just being able to simplify a square root that has a negative inside. So again, we have no real solutions here, but we have two complex solutions. All right, so go ahead and pause the video and give this problem a try on your own. Solve using the square root method, and then we will check your answers in just a few seconds. All right, so go ahead and check your answers. So first we need to isolate x squared. So you should get x squared equals negative 27. Then you can take the plus or minus square root of each side. So although this is not really possible to take the square root of a negative, anytime we have the negative inside, put the I on the outside. And then we do need to simplify square root of 27, which is 3 root 3. So our answers are plus or minus 3i root 3. All right, so now we're going to try solving this quadratic with a different method. So we're going to be completing the square. So again, let's start with that first step. We are going to be moving our constant to the other side of the equation. And I'm going to move my work over to here. So that gives us x squared minus 2x equals negative 7. So now we need to find that magic number that completes our square. So we do b divided by 2, and then we square it. So that gives us negative 2 divided by 2, which is negative 1. And negative 1 squared is positive 1. So we add 1 to each side of our equation, and we're left with x squared minus 2x plus 1 equals negative 6. So this should be a perfect square trinomial. So you can check by factoring it. So what multiplies to make 1 adds to make negative 2, negative 1 and negative 1, or x minus 1 squared, since it's the same factor twice. And from here, to clear the square, we take the plus or minus square root of both sides. So x minus 1 equals plus or minus square root of negative 6. So here, again, we will have that imaginary number. But before we deal with that, let's finish solving for x. Let's add 1 to each side. So this gives us x equals 1 plus or minus I root 6. So remember, a negative on the inside gives us an I on the outside. Also remember, we can't add a non-radical with a radical, so our answer is going to stay separate. So here are our two complex solutions, 1 plus I root 6 and 1 minus I root 6. All right, let's try another one together. So same process, we're going to start by subtracting 26 from each side. So this gives us x squared plus 10x equals negative 26. Now we need to find the magic number that completes our square. So we do our b value, which is 10. We divide it by 2, which is 5, and we square it. So our magic number is 25. So I'm going to add 25 to both sides of our equation. So we get x squared plus 10x plus 25 equals negative 1. So this is a perfect square trinomial. If you factor it, you should get the same factor twice. We should get x plus 5 squared equals negative 1. To clear the square, we take the plus or minus square root of both sides. Don't forget that plus or minus. All right, and then we do need to finish solving for x. So we do need to subtract 5 from each side. So we get x equals negative 5 plus or minus. And remember, by definition, square root of negative 1 is I. So it's plus or minus I. And those are our complex solutions. So again, this quadratic equation has no real solutions, but it has two imaginary solutions. All right, so I have one for you to try on your own. So go ahead and pause the video and give it a try, and then hit play when you're ready to check your answer. All right, so go ahead and check. Move your constant to the other side of the equation. In this case, our magic number is 16, so add 16 to each side. This trinomial becomes x plus 4 squared, so then we could take the plus or minus square root of each side, and then finish solving for x. Just remember, square root of negative 1 is by definition now I. So here's our two answers, negative 4 plus or minus I. So there is actually a way that we can identify in advance the number and type of solutions that we can expect for any quadratic. And that will lead us back to the quadratic formula, which is right here. So the three options that we have for quadratics are we might get two real solutions, we might get one real solution, or we might get two imaginary solutions. So let's start by deciding what part of this formula would determine whether our solutions are real or whether they're imaginary. We know that the imaginary solutions come into play when we're taking the square root of a negative number. So that means that any time all of this stuff under our square root, this b squared minus 4ac, anytime this is negative, or another way of saying that is less than 0, we know that we're taking the square of a negative, and that gives us imaginary solutions. Now that means that as long as this is not negative, we're going to get real solutions. So let's talk about, well, why is it sometimes we get two real solutions and why do we sometimes get one? So you can probably figure out that the reason why we often get two real solutions when we're using quadratic formula is because of that plus or minus sign. So the plus gives us one solution, the minus gives us another solution. So how can we make this plus or minus sign disappear if this is equal to 0? So if whatever is under your square root is equal to 0, like we would see here, that means that your square root disappears altogether, and then you no longer have the plus or minus sign. And if the plus or minus sign is gone, you only end up with one real solution. And then of course, if whatever is under your square root is just any positive number, we can take the square root of that, so it's real, and the plus or minus is still going to be there, so we do get 2. So this thing that we're looking at, that b squared minus 4ac, it's so important that it has a specific name. It's called the discriminant. So again, the discriminant is that b squared minus 4ac. So notice the discriminant doesn't include the square root. It's just the stuff that's underneath the square root. So just by looking at the discriminant, if you plug in b squared minus 4ac and you get a positive number, you know that you're going to get two real solutions. If you plug into your discriminant and you get 0, if your discriminant is 0, you know that you're going to get one real solution. And if your discriminant is negative, that's how you know that you're going to get two imaginary or complex solutions. So you're going to see how this discriminant is going to affect us in the next couple examples. Okay, so we're going to be solving this equation using the quadratic formula. So remember, the first step of using quadratic formula is we need to make sure our equation is set equal to 0. So I'm going to start by subtracting 8 from each side. So we get negative 5x squared minus 2x minus 8 equals 0. So now we have our a value, which is negative 5, our b value, which is negative 2, and our c value, which is negative 8. So let's just check the discriminant really quick over here on the side, b squared minus 4ac, just so we can see what type and how many solutions to expect. So this gives us negative 2 squared minus 4 times negative 5 times negative 8. So this gives us a discriminant of negative 156. So since our discriminant is less than 0, we know that we're going to have two imaginary solutions, so we can expect that. So now we can do the full quadratic equation. So x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So this gives us 2 plus or minus the square root of negative 156 all over negative 10. And now we're going to need to simplify square root of 156. And we'll take care of the negative as well. So remember, when you're simplifying a radical, it's nice to look for things, perfect squares that divide in evenly. So I tried dividing by 4, and we get 4 times 39. So the square root of 4 is 2. So this just becomes 2 root 39. And we can't simplify square root of 39 because it's not divisible by any perfect squares. So now we can write our answer as x equals, I'm going to move this negative up in front of the 2. So negative 2 plus or minus, so we have the 2, and then remember we have I because of the negative. So 2I root 39 all over 10. And then we do have one more step. We can see here that these three numbers, our three coefficients, are divisible by 2, so we can simplify a little bit more. So it gives us negative 1 plus or minus I root 39 all over 5. So always check to make sure that your answer is fully simplified. But again, since our discriminant was less than 0 or negative, we do end up with 2 complex or imaginary solutions. All right, so I have another U-try for you guys. So please pause the video and give it a try, and then we'll check your answers in just a few moments. All right, go ahead and check your work. So first you do need to make sure your equation is set equal to 0. So you do need to subtract 2x from each side. So that does need to be your very first step. From there, we're simply plugging in our a, b, and c values into our quadratic formula. So you can see here that we end up with the square root of negative 12. So we know from here that we're going to have this imaginary number. And the square root of 12 is 2 root 3. So we get 2I root 3. And the last step, you do need to simplify a little bit more because 6, 2, and 2 are all divisible by 2. So you should get negative 3 plus or minus I root 3. All right, so the last thing we're going to do together is we're simply going to determine whether the solutions of the following scenarios are real or imaginary. So here we have real life examples. So by checking the discriminant, we can see if it's worthwhile to solve them. Because of course, with a real example, we don't want any imaginary solutions. So this first part says, a ball is thrown in the air with an initial velocity, or vertical velocity, of 14 meters per second from an initial height of 2 meters. The ball's height, h in meters, at time t in seconds, can be modeled with this quadratic function. Does the ball reach a height of 12 meters? So we can essentially substitute 12 for the height because it does say height of 12. So we're going to substitute it for our y value or our output. So we get 12 equals negative 4.9 t squared plus 14t plus 2. And then here, we're going to set it equal to 0 so we can check our discriminant. So again, we're not actually solving, we're just seeing whether the solutions are real or imaginary. So let's subtract 12 from each side. So 0 equals negative 4.9 t squared plus 14t minus 10. And then we're just going to be doing b squared minus 4ac to see if it is positive, negative, or 0. So let's plug in our values. So 14 squared minus 4 times negative 4.9 times negative 10. So this actually gives us exactly 0. So since our discriminant is equal to 0, that tells us that we would have one real solution. So since we do have one real solution, we do know that the ball actually does reach a height of 12 meters because, again, this quadratic equation has a real solution. All right, let's try part B. So it says a person wants to create a vegetable garden and keep the rabbits out by enclosing it with 100 feet of fencing. The area of the garden is given by this function, where W is the width in feet of the garden. Can the garden have an area of 700 feet squared? So is it possible? So here we're going to be substituting 700 for the area, and then we're going to be seeing if this creates a real solution. So we have 700 equals W times 50 minus W. So if we want to check using the discriminant, we are going to need to put it into standard form and set it to 0. So let's start by distributing. So we get 50W minus W squared. So let's actually move these terms on the right to the left side of our equation. So let's add W squared to both sides and subtract 50W from both sides. And now we can check our discriminant. We'll do B squared minus 4AC. So that gives us negative 50 squared minus 4 times 1 times 700. So this gives us a value of negative 300. So our discriminant is less than 0 or negative, which means that we're going to get two imaginary solutions or two complex solutions. So that means that since we don't have any real solutions, the garden would never actually reach an area of 700 feet squared. So this is just an example of how you can use your discriminant to check different models to see if real life scenarios are possible or not. All right, so that is all for today's video. Thank you guys for watching.